Alright, so this is chapter 3, which is polynomial functions. Now be very careful. One thing that you need to understand is what is a polynomial and what isn't a polynomial. So a polynomial has nice exponents. Okay, that's what makes it a polynomial. So the exponents are whole numbers. The exponents cannot be negative, and they also can't be in a denominator. So when you have something in a denominator, remember that's actually a rational function. So again, to be a polynomial, you have to have nice exponents. Let's take a look at this then. This is just on page 106, and it's a little investigation that you can go through that compares all the different sets. Alright, so let's start by taking a look at which of these are polynomials. So remember that to be a polynomial, n has to be a whole number. It can't be a fraction, it can't be a negative, and again, that's the exponents. It has to have a variable, so we'd say x is the variable, and the other coefficients are real numbers. They, though, can be fractions and they can be negative. So the leading coefficients can be negatives or fractions, but the powers have to be nice numbers. So let's look at the first one. A, is this a polynomial? Yes. You even know the kind of polynomial. This is a parabola, a quadratic function. Okay. So yes, this one is a polynomial. How about B? Is this a polynomial? No, it's not. You guys already know what kind of function this is. This is a radical function. A radical function, remember, had a root in it. So this is a root function, which means a radical function. Let's look to C. Is this one a polynomial?
Yeah.
Okay, this one is a yes. Notice that there's a fraction as a leading coefficient. That's okay. But if you look at the powers, they're 5, 4, 1. They're nice powers. Again, that's what we're looking for. And the last one, we have a fraction here. No. So this one is not. We also know that this one is called a rational function, because we just did that. Rational functions are those functions that have an x in the denominator. So next we're just going to fill out this table. Now certain polynomials are given special names. So if you have a polynomial that's just a number, this number is called a constant. So we call that a constant function. And remember that a constant function in this case would just be a horizontal line. So you would just have a linear function, but that is a slope of 0, so it's a horizontal line. Now, I see that some of my symbols didn't work out here. This should be minus 6x minus 5. It should say that on your sheet. This one has a degree of 1. So if it's a power 1, we call that a linear function. It just means a straight line. The next one, x squared plus 4x minus 15. This one has a squared as its highest power, and we call that quadratic. Again, you guys have done those ones so far. The next one here is 2x to the power 3 minus 4x squared plus 1. Here the highest power is a power of 3. A power of 3 we call a cubic function. So again, if it's degree 3, we call it cubic. These last two you probably haven't heard of before. First we have a power of 4. If you have a power of 4, it's called quartic. I always think like a quarter, right? A quarter is a 4, if you think of it as 1 over 4. Okay, so it's called quartic. And then the power of 5 is called quintic. So you have a quartic for 4, a quintic for 5, and you're going to need to know those names. Now the total possible number of x-intercepts, you'll notice in the first few tables here that are filled out, here there's 0 x-intercepts because it's a degree of 0. Again, that doesn't mean there's exactly 0, but that's the maximum there could be. If it's a power of 1, there can be maximum 1 x-intercept. And think of it, you guys, if it's a line, right, it would hit the x-axis once. A quadratic is a parabola. That means it's got a degree 2, and it could have 2 x-intercepts. So let's fill out the rest of the table. A cubic is a degree of 3, so it could have a maximum of 3 x-intercepts. A quartic, a degree 4, could have a maximum of 4 x-intercepts. And a quintic with degree 5 could have a maximum of 5 x-intercepts. Now let's also look at the leading coefficient. Remember, the leading coefficient is the number in front of the highest powered term. Okay? So here, the leading coefficient is just 5. Here it's minus 6. And here it would be a 1, because there would just be a 1 in front of the x squared. Let's go to the next one. Leading coefficient would be 2. This one? Negative half. Good. And the final one? 3. Good. Those are our leading coefficients. Now the final column we've got is your constant term. I want you to please write this down. The constant term is your y-intercept. The reason it's your y-intercept is because if you plug in 0 for your x's, there would be nothing left except the constant, except the thing at the end. So let's take a look at our constants. Again, here it's 5, negative 15. If I like to my next one, the term without the x is just a positive 1. Here the term without the x is a negative 9, and here the term without the x is a negative 2. So in this one we want to find the degree, the leading coefficient, and the constant term of this polynomial. But what's tricky here is that it's in factored form. So let's think about what this would be if you expanded it. So this would be x to the power of 3, and then we'd have 2x minus 1 3 times, because it's cubed. So really, this is what our function would be. Now, I do not expect you to have to FOIL that all out. That would take you forever. Okay, there's an easier way to find this information. So let's first think about our leading coefficient. Okay, our leading coefficient would be all of these front numbers multiplied together. Because if you FOIL something, it's the front times the front. Okay, so if I look here, that'd be x cubed times 2x times 2x times 2x, which means I would have 8, because 2 times 2 times 2 is 8, and then x, but what would the power be on the x? 6. It'd be 6, because we have a power of 3, and a power of 1, a power of 1, and a power of 1. So there'd be x to the power of 6 at the beginning. Now, I really don't need to know any of that middle stuff, but let's think about the last part. Remember, the last part would be the last parts all multiplied together, but also multiplied by that x cubed, because that x cubed would go into everything. So we'd have minus 1 times minus 1 times minus 1 is a negative 1, but I'd also have that multiplied by x cubed. So this function would have an 8x to the power 6 at the start, and a negative 1x cubed at the end, and then there'd be a bunch of stuff in between. So now let's look at this and figure out our leading coefficient. And I call the leading coefficient LC. I hope you're okay with that. What does the leading coefficient equal? 8. Good, that's my front term. Good. The degree. The degree is 6. Good, that's my highest power. And then let's also look at the constant, and this is tricky. There isn't one. Good. So if there isn't a constant, we say 0. Because you could actually tack on a plus 0 at the end here, and so the actual number 0 would be your constant. Alright, so just to remind you how the quadrants go, it goes 1, 2, 3, and 4, so you're going to need to keep that in mind. Also keep in mind that when you read a graph, it goes from left to right. So this one, we'd say that this one starts in quadrant 2 and ends in quadrant 1, because we always read a graph from left to right. So what we really have here then is 4 different options for end behavior. You can pause the video here if you want to take more of a look at these. But let's get into showing you my trick. So I'd like you to please write this down. So here's how I think of our end behaviors. There are 4 options. So we're going to start by drawing 4 graphs on our page. If you think of your most basic odd function, your most basic odd function would be y equals x. Okay, y equals x is a power of 1, so it's an odd degree, and the leading coefficient would also be positive. If you think about what this shape is, it's just a linear function that would go from quadrant 3 to quadrant 1. So this is the case if it is an odd degree and a positive leading coefficient. So again, if the degree is odd and the leading coefficient is positive, you're going to get a function that looks kind of like a line, and a positive sloping line. So it's going to go from 3 to 1. The other option on that would be if your line was a negative leading coefficient, so a negative x. Now the graph y equals negative x is a downward sloping line. So it goes from quadrant 2 to quadrant 4. The downward sloping line still has an odd degree, but this time it has a negative leading coefficient, which makes it again slope downwards. So that's kind of your second option. The third option would be if you have a even power. Now our basic even graph is the graph of x squared, so just a parabola. And remember, the basic parabola has a vertex at 0, and it opens up. So this one would go from quadrant 2 to quadrant 1. And again, this is the case where the degree is even, and the leading coefficient is positive, again, because it's opening up. So if it opens up, it's going to be positive, and the even degree makes it look kind of like a parabola. The final case you probably guess is if there is a negative out in front. Remember that a negative parabola is flipped upside down. And again, this upside down parabola would have an even degree, but this time it has a negative in front, so it's got a negative leading coefficient, and it would go from quadrant 3 to quadrant 4. So those are kind of the 4 different cases. So always think to yourself, okay, is this like a line or is this like a parabola? Does my line or parabola go up or does my line or parabola go down? Kind of what you think as you go through this. Alright, on these ones I'd like you to go through them and again try these on your own. We will go through the answers. The first one has a highest power of 15, so it's odd, and has a positive leading coefficient in front of that. So if it's positive and odd, it's going to act like a line. So it would go from quadrant 3 to quadrant 1. So we say Q3 to Q1. The next one has a power of 10 as its highest power, and a negative out in front. So if it's a power of 10, that means it's even, so it's going to act like a parabola. And if it has a negative out in front, it's going to act like the negative parabola. So it'll go from 3 to 4. Now the last one is tricky because the last one's in factored form. So remember that you'd multiply all the front parts together. So what I'd have here is an x to the power of 8, because there would be 8 of those x plus 3 factors. And then I've got 5 of the 2x factors. So 2 to the power of 5 is actually 32. If you go 2 times 2 times 2 times 2 times 2 is 32. And there would also be an x to the power of 5 attached there. So again, if you finish this off, we have a minus 2 times a 32 is going to give us minus 64. And an x to the power of 8 multiplied by an x to the power of 5 would give me a total of 13 x's. So this one is actually a negative leading coefficient with an odd degree. So it's going to act like a negative sloping line. Odd degree is like a line, and it's negative, so it's going downward. So that would go from quadrant 2 to 4. Good. All right, so looking here then, which one matches up with which? You guys, there is something. All right, so when I look at the first equation here, I know that I have a negative in front and a even power, so it's going to be like an upside down parabola. So that should match with this graph, A, because this one is the one that looks like an upside down parabola and goes from 3 to 4. The next one, be careful. The leading coefficient is a 1 and the power is a 3, because the x cubed is actually the biggest power. So you look at the leading coefficient in front of that. So again, this is an odd, so it's going to be like a line, and it's a positive in front, so it's going to be like an upwards line. So that should match with 4, an upwards line. This one, the leading coefficient is negative, and the power is odd. So it's going to act like a line, but it's going to act like a downwards line. So that would match here with the first one, C, which should mean that our last one here, D, would match with 2. Again, because if you look at the front term, it's going to act like a parabola because it's even, and it's going to be an upwards facing one. So it's going to go from quadrant 2 to quadrant 1. So that would be D. All right, your assignment questions then, page 114, 1 to 6. Choose at least 2 letters from each.